Hello all and welcome to the Department of Physics and KTHM e-learning channel. Today's topic will be optical telescopes and mounting of telescopes. In the last two lectures we have studied we started studying astronomical instruments. In that we have started studying optical telescopes. In last lecture we have seen different types of optical telescopes. Before that we have seen the basic things which are necessary or that we should know before starting to study the observational astronomy, uh, which can be studied by using astronomical instruments. Now in last lecture we have seen that there are two types of optical telescopes depending upon which type of objective we are using. So the first type of optical telescope that we have seen is a refractor telescope or refracting telescope, and the second type is a reflecting telescope. We have also seen that the objective of the refracting telescope is a glass lens, okay, through which the light passes. After that it gets refracted, then it is again incident on the second lens, okay. After that the image is getting formed at the focus of both the lenses. Again we have seen there are certain drawbacks of using a refracting telescope, such as a chromatic aberration. So due to that, the most widely used optical telescopes are the reflecting type of telescope. And in this lecture we are going to see different types of reflecting telescopes, okay. Now the basics of reflecting telescope, we know the objective of the reflecting telescope is a concave reflector objective that we can see over here, okay. This is the objective and this is the eyepiece, and this is the object which we are going to observe, or that is the celestial object which is far away from us. Now the light which is coming from that object is first incident on the reflector objective. From that the light rays gets reflected and it is again incident on the eyepiece, okay, which is again convex lens of a short focal length, through which we can observe the images, okay. And the image is getting formed at the focus of both the lenses, that is a reflector objective and the eyepiece. Now one drawback of this reflecting telescope is that look at the position at which the image is getting formed, okay. So when an observer is observing, okay, he has to observe this object from here, okay. So when he is observing, what is the drawback is some of the light which is coming from that distant object, there is a possibility that that light will be getting blocked, which will again hamper the formation of the image, okay. If the light is not reaching our objective only, how can the image will be getting formed? So to avoid that, certain or different scientists tried different methods, okay. So the first scientist was Newton. He used a different technique to avoid or to come over this drawback of the reflecting telescope. So what he did is his telescope is known as a Newtonian telescope. Now we will see the different parts of Newtonian telescopes, then we will see the mechanism, how it works, and what is the difference between the normal reflecting telescope and a Newtonian telescope. So again it is having a reflecting or a reflector objective. The extra thing which the Newton has used is he placed a reflecting mirror in the principal axis of the reflector objective, and eyepiece is placed at this position, okay, which is approximately 90 degree to the reflecting mirror, and reflecting mirror is at a 45 degrees angle. So what is happening is when light rays is coming from the distant object, okay, it is incident on the reflector objective. From that again it will get reflected, it will be incident on a reflecting mirror. From that the light rays will get again reflected to the eyepiece, and from here an observer can observe the formation of the image, or the object which is being getting observed through this telescope, okay. So the drawback which we were talking about earlier is that in the normal reflecting telescope, what was happening is the eyepiece was here. So when a person is observing through that telescope, he has to observe from here, which is which can block some of the light which is coming from that object. That is why this position of the eyepiece here, it gets changed. Okay, and a person can observe through this telescope without blocking any of the light which is coming from the distant object. Okay, so this is the arrangement of the Newtonian telescope, and this is the ray diagram that you should know. Okay, and so it is useful, or very very useful, to overcome the drawback of the reflector telescope. Okay, now again, Newtonian telescope is overcoming one of the drawback, but it has its own drawback, and that is to balance the, like see, this is the telescope. Now all these instruments are fitted inside one tube. Getting it? Now reflector objective, again we know that higher is the or greater is the diameter of objective, more greater quality of images are getting formed. Okay, so the reflector objective has its own weight, the mirror has its own weight, the tube has its own weight. Okay, so while mounting this eyepiece and deciding the position of the mirror, we have to take into consideration the center of mass of that telescope. Okay, which has to get balanced, or due to if it is not balanced, then the stability of the telescope will not be there. Okay, so this is one of the tiniest drawback to the Newtonian telescope. So there is another scientist, that is Cassegrain. He came about, or he designed a different telescope to overcome again this drawback. So the second type of optical reflecting telescope that we are going to see today is the Cassegrain telescope. Now again, we will go in the same flow. First we will see the instruments which are used in this telescope, and then we will see how it works. Again, Cassegrain telescope is a reflector type of telescope, so it has a reflector objective. Okay, so the one thing that we can see over here is the objective, the reflector objective in this Cassegrain telescope is not the one single piece. Okay, it is having a hole in between that. Okay, we will see the purpose of that hole. The second instrument, or the second thing that is used is one secondary convex mirror is used. Okay, which is placed on the principal axis of the reflector objective. This is correcting lenses, and eyepiece is on the back side of the objective. Now as the light is coming from the distant object, it is first incident on the reflector objective. From that, it will be reflected towards the secondary convex mirror, which is placed on the principal axis of that reflector objective. From that, it will be getting reflected back to the eyepiece through the hole which is made on the reflector objective. Okay, so what is happening is, now what are the differences between the Newtonian telescope and the Cassegrain telescope? The major differences are the reflector objective. Okay, it is not a single piece, it is having a hole in between that reflector objective, and a secondary mirror, that plane mirror is getting converted into a convex mirror. Okay, or it is replaced by a convex mirror. Now what are the advantages of using a convex mirror is that it gives you a higher focal length. Okay, due to the convex mirror you get the higher focal length. Due to higher focal length, the quality of the images which are getting formed of the distant objects, it gets improved. Okay, and you get higher focal length, and it can be fitted inside a narrow tube. Okay, large focal length in a narrow tube you get due to the secondary convex mirror. So this is one of the advantage of Cassegrain telescope. And the second advantage is what, in the Newtonian telescope we have to adjust the position of the secondary mirror and the eyepiece so as to balance the center of mass of that telescope. Okay, so that thing which we have to adjust in the Newtonian telescope gets cancelled out here. In the Cassegrain telescope, the position of the eyepiece is at the backside of the reflector objective. Okay, so there is no need to balance the center of mass and everything of that telescope. Okay, again you have to consider or take into consideration that all these objects are fitted inside a tube, getting it, and at the back end of that tube there is a eyepiece through which an observer can observe the distant objects. Now third type of telescope that we are going to study today is the code telescope. Now what is the difference in code telescope is it is having a paraboloid mirror, a convex secondary mirror, and a plain reflecting mirror. Okay, so the light which is coming from the distant object is first incident on a paraboloid mirror, will get reflected to the convex mirror, from that it will be reflected to the plane mirror, from plane mirror it will be reflected towards the eyepiece. Okay, again there is a thing that we have to consider here is like a Newtonian telescope, we have to take into consideration the center of mass of this telescope while arranging the plane mirror and the eyepiece. Okay, so this is the drawback, but what is the advantage of this telescope? Due to paraboloid and the convex mirrors which are used as an objective, okay, we get a higher focal length in a smaller tubes. Okay, so the size of the telescope becomes compact, okay, and it becomes easy to handle, easy to get handled. So this is the third type of telescope that we have studied today, is a code telescope. So these are the different types of reflecting telescopes which are widely used for the observational purpose in astronomy. Now the second thing that we are going to study today is mounting of the telescope. Okay, now what is mounting of the telescope? Now to observe the celestial objects, okay, in a right direction, we have to mount all those telescopes in the right way, okay, or in the right direction, so that you what desired object you want to observe in the sky, you can point your telescope towards those objects correctly. So that is why mounting of the telescope is again a very important thing that we have to study. Now again telescopes are having two main parts, that is optics of the telescope and mounting of the telescope. Optics we have studied, it is having objective and eyepiece. Depending upon objective, different types of telescopes are there, and these two things are aligned or mounted in a closed or open tube. Okay, now mounting of telescope is of there are two different types of mountings. One is called as a equatorial mounting, and second one is called as a azimuthal mounting or alt azimuthal mounting. So we'll see what are these two types of mountings and how to mount the telescopes in these two, how the telescope is mounted in these two types. The first one is equatorial mounting. Now in a equatorial mounting, one axis of the telescope is made parallel to the Earth's axis of rotation. Okay, one axis is made parallel to the Earth's axis of rotation, and it is called as a polar axis. Okay, what is Earth's axis of rotation? North south. Okay, and the Earth is rotating around this north south axis. So one axis of the telescope is made parallel to this north south direction. Then the other axis is perpendicular to this polar axis, and it is called as a declination axis. Okay, the other perpendicular axis is called as a declination axis. Now if telescope is mounted at one end of the declination axis, a counterweight is attached on the other side to balance the weight. Okay, to balance the center of mass of the telescope. Now this type of mounting is called as a equatorial symmetric mounting. Now telescope can be pointed north or south in declination by rotating around the declination axis. Okay, again, to observe the different things or celestial objects in the sky, you have to your telescope has to be moved in a particular directions. Okay, so those directions are your telescope should be able to move in a north south direction as well as east west direction to track a star or an planet or any object that you are going to observe. Okay, so the telescope can be pointed in a north or south direction by rotating it around the declination axis, and it can be moved east or west in an R angle by rotating the declination axis around the polar axis. Okay, both these axes are perpendicular to each other, getting it? So one axis is giving us the movement in north south direction, other axis is giving us the movement in the east west direction. So if polar axis is itself is rotated at sidereal rate, what is sidereal rate? It is a rate of Earth's rotation by driving mechanism, then a star can be kept in a view continuously, getting it? Now if the polar axis is rotated at the sidereal rate is Earth's rotation rate. Okay, so the position of the stars, okay, or the planets or any object changes in the sky due to the Earth's rotation around its own axis. Okay, so if the rate of change of rotating the telescope around the polar axis is matched with the sidereal rate of the Earth's rotation, so a star can be kept in a view continuously. Okay, if you have pointed towards a particular star, that star will be in focus continuously. Now the second type of mounting is a azimuthal mounting or a alt azimuthal mounting. What is azimuth? That we will see later. First we will see what is azimuthal mounting. Now for a massive telescope, it is more convenient to choose one axis vertical and one horizontal for mechanical stability. So rotation around the vertical axis changes the azimuth, while rotation around the horizontal axis changes the altitude. So to keep a star in view continuously, one has to move the telescope around both the axes at different rates, which is best achieved by the computer control. This angle, so what is this angle? Is the angle which is made or the angle between the celestial body and the north, which is measured clockwise around the observer's horizon. Okay, an observer is observing from here to this star. Now the angle made by between the celestial body and the north. Okay, so this is the celestial body which is being observed, and this is the north of the observer. Okay, so the angle which is made by the celestial body and the north, which is measured clockwise around the observer's horizon, this is called as the azimuthal angle.